And good morning. We're going to be working on text character placement. Now, what I'd like to do is split up render state so that we can make some of this testable. Some of this we cannot currently test because it would have to be tested inside of Godot. And scene switcher's not started. Let's try this again. Yay, look at that. All right. And good morning, everyone. All right. So, because some of this is containing Godot types, like multi-mesh instance, and let's see, anything inside of here? Yeah, array mesh. We cannot actually test these inside of the test harness. We could only test it inside of Godot, unless we build something out for our tests that, well, substitute this stuff out. So we could create a trait, have render state implemented, whatever the trait is, and then we swap it out. For the test, we use the test Godot stuff, and for Godot, we use the Godot stuff. So we're going to do that, and then also in text layout, we're going to work on this multi-line layout, and we'll be dividing this into, well, scanning through it, splitting it up into lines. So when we get to a white space, we'll remember when that last white space is, and start to word wrap this, hopefully on whole words. But I would really like this tested because it feels quite shaky at the moment. And we're going to break it down into smaller pieces just to make sure that it works correctly. Get our units for unit testing a little better. Now, let me go. I'm going to update the today command. Today's pretty good. We'll leave it. It's kind of generic, but it's still good. Now, for our multi-line layout, what we need to know is that given a certain character, what are the properties of the character? So given the letter A, how wide is it? What does the character advance for this? When we get to a new line, how far do we need to move down in order to start the next line? So we could toss that into some sort of trait. And then we could take something here that would be the same sort of thing. We could also try to use trait objects. Ooh. Make this a dynamic render state. I haven't used that much at all. Maybe we should try it. I mean, most of the time I'm spending on basically generic bits, generic arguments, and I spend hardly any time on dyn here, or other trait objects. So let's make this compile first. Undo some of this, and then oops, that back, take that off. I'm going to rename render state to maybe Godot render state. Who needs one of these? Text does. And text layout needs it. Let's rename this to Godot render state. Then we'll have it impl trait.
Red stain on the grain of the timber, obscured in the trees and the towns. There's a sinister scent on the wind. Time's gonna come around. The red sun is going down. There's a devil inside of us all now. There's a giant to bring to the ground. He's taking us out when it falls. Our time's gonna come around. The red sun is going down.
Toss one of those on there. We're going to need this horizontal edge. What else do we need in there? We need a vertical advance. Let's just call it vertical advance. Whoa. Huh. Maybe we should call that something else instead of horizontal advance, vertical advance. Let's just write it out. Okay, so now that we have those there, we can get rid of this. Oh, interesting. That should probably take self, even though our implementation won't use it. Although it could. Because we don't keep the font face in here. We could absolutely do that. Even though our Godot one is only going to get it from where? We won't have it implement default. Let's have it implement new. Generate a new. There we go. Now, the only piece I think that we need is that one. Give that a save. Okay. Most of these are just going to be their defaults. Which ones? The middle three. Morning, Nightshade, dude. 3D font. Yeah, we are working on rendering meshes in 3D space. So, there we go. We're taking TrueType font. It's render data. Let's see, did that switch correctly? So this is what we're going to be building out. And then if we wanted to, we could kind of extrapolate a little bit, make it a full mesh, make it watertight. But at the moment, it's really 2D fonts in 3D space, which I'm going to be tossing shaders on so that we can get some interesting effects on it. Font data. I forget. Where were we using that? Go look at font. Oh, we just call face from font. That's right. That's right. Vertical advance. You know what? Let's extract that to a local. Ooh. We gave it a good variable name. Wow. Let's see if it's a vertical ascender. I don't know which one it's going to be. TF font vertical ascender. I want to see what these different properties mean. Let's see. I know that we saw something before that described these. Oh, is the vertical ascender just the bit at the top? Descender. Okay, so we might need the ascender plus the gap. Vertical ascender plus vertical line gap. Ooh, missing a lifetime specifier. We could just get rid of it. Because we don't have to do that, and putting that in there would cause some issues. Well, it would cause a lot more refactoring than I want to do at the moment. Oh, there are options. That's right, because they don't always have it. And so if they don't have it, what do we use? Wrap for default? Use 0? That's kind of gross. Expected U16 found I16? Really? Okay. So that is an I16. That's surprising. Well, kind of. It's kind of surprising. Because when would the center go negative? I guess you could with font, right? Kind of bring them closer together. That would be odd, but possible. All right. So this no longer has default. Yes, which means that we need to now pass this in. Something like that. Render state doesn't have, is it not public? Oh, I called it Godot render state. That works. All right, what else? Unnecessary qualifier. Oh, because we're in a trait. Of course, all functions and traits are public. What else do we have? Come on, give me the errors. Technically, we do not need that. Okay. So that builds. But now we can take a render state, and then also have we can have a test render state for our multi-line text rendering, so we can make sure that that is tested properly. All right, I'm gonna skip forward on this song. I don't know. I just don't feel that one, you know? All right. I'm thinking I want to get the render state left in this file. I want to extract the Godot render state into its own file. Good morning. Oh my goodness, I'm going to stumble over your name. Indefit, indefit, indefatigably. Well, good morning. So far, what I have is this, which is the screen. The game itself. Here we have what looks like a calculator, but we have yet to put the shaders on these meshes. So these are meant to look like kind of some sort of UI that is suspended in 3D space, kind of like one of those next-gen touch screens that are holographic almost. And right now we're working on the text rendering for it. So we'll have the texts up here for the screen, and then also on the buttons. Well, this is what we have so far. Oops, almost. It's... Oh, interesting. Today actually worked with that I at the end. That's unsettling, but neat. Oh, no, that's not it. That I want today. So we did that at the same time. But I'm actually working on this littler game at the moment. A little bit of a psychological thriller, so it's going to have a lot less UI, because I don't want to take away from everything that's building up in your mental picture, your idea of what's happening in the game. So I've already got some music, some really great music. It was on Humble Bundle, this horror bundle of game music, royalty free, yada yada. Got like hundreds of hours of horrible, scary music. Yeah, just taking a little break from Legacy. Trying to get something done that I had been also wanting. But because getting back into Legacy, I want to do some updates to Packeteer, that networking piece of it, because portions of that are, well, I think there's some improvements in Tokyo that would end up changing how Packeteer works just a little. Let's see, do I want these to actually return options or 0. If I do like them returning option. That, and it's not quite right. Because in render state, we actually stuff two things into vertical advance. Or Godot render state. Uh-oh. Let's put that in the other file. Good. Get rid of that. Probably some of those too. Toss that in there. Now, when we come back to Godot render state, and we have this vertical advance, this isn't quite right. I'm going to take that out of there too. I don't know, where should we put that? Probably with the implementation. It could be at the bottom of the file. But for now, it's going to sit there. I think I want the vertical ascender and the vertical line gap both as properties here, and both in the trade object. So we have the ascender. Look at the vertical line gap. We're going to go ahead and use those signed ones. All right. And this is going to be simplified quite a bit. We're not going to do the unwrapper default. We'll just keep it. Here we go. And see, those are actually options. Huh. Well, that's funny. I don't remember my key sequence for surrounding these things. Oh, there it is. Huh. Well, that was weird. All right. Vertical advance. Vertical advance, and then the other one, vertical line gap. All right. So JT, how much of it did you listen to? I've gone through a bunch of them, and it's interesting how subtle the differences are, but they are exactly like what they are described to be. Right? Some are like the romantic ones, some are horror, some are kind of suspenseful. It's really neat. They've really captured the essence of what that sounds like. Okay. There we have those. Good, good. These look pretty good. Yes, and most of this is not needed. Feel so alone now. Why not? Do you just not know where it is? Oh, because I didn't import it in text mod. That one we can re-export. That one's fine. Now there's going to be another function that we need to implement on that trait. So we added a couple of functions that give us information, but we also need to be able to set, or rather mutate something. Now Godot doesn't have... Godot does a lot of interior mutability, so we'll just take n's references to self function set transform. We'll have to give the character which index of it, or rather which character. That'll be a U size, and then also the transform. And by doing that, we should be able to keep, well, for our test one, keep information about what is where. But then for the Godot one, we'll be able to set those functions directly on Godot. Over for our test one, I don't want to implement interior mutability, so we will not have interior mutability for our trait object. All right, we're going to come back to Godot render state. Where's our implement? Here we go. Implement missing member. Oh, what's wrong with this? Oh, the sign. They're optioned I16 here. Oh, at the end of that. Got it. Okay. So now for the set transform. And we'll have to find the glyph. Self.glyphs dot. Maybe we should use entry here. No, we'll just do a get. Give it the character. Now this will return option to the value. What should we do if it's not there? Should we panic? Or do nothing? Should probably at least scream loudly. Let's give that a match. Still match arms. If it doesn't exist, in this case, we'll call Godot error. and then we need to return. What does Godot error actually return? Can I just return it? Does it return unit? Is really what I'm asking. Okay, looks like it does. So now that we have the glyph, if we look at glyph, we have these multi-meshes here. And we should be able to set the transform on a specific index of a multi-mesh. Do we have a function for that already? That doesn't look like it. You know what? Let's go ahead and create one. The transform. This one doesn't need to be mutable. We already know what the character is. So in this case, we want the index along with, oh, the transform.
Doesn't feel like yesterday. It feels so far away. Now you're gone out of my life.
Need the docs on this one.
Simple things take more heart to lay it down. Where would I start?
Do I have that already open? Yes. Go to the latest version. Multi-mesh has it's got some setters that let you set the transform of a specific instance of a mesh. Set instance transform. There it is. Oh, they're using i64s because, of course, you can use negative numbers for this. No, it's just because that's how Godot did their cross-platform GD native APIs. Internally, I think it has F64s and i64s that it uses all over the place. Maybe for GD script? I don't know. We'll set the instance transform ID followed by the transform. Great. Index is blah, and then transform. Done. And this is the right kind, isn't it? Okay, GD native. Okay. Good old negative counts, yes. Alright, set instance transform. Oh, okay. I forgot to take that out to a array mesh. Excuse me. We need to do some assume safe on this. Extract into variable. Multi-mesh. Unsafe. Assume safe. Basically, we're promising that we've done the check. We understand that this is safe, and we can get an instance to that. Coming back here, glyph dot set transform. Do we just set instance transform? Maybe. What's an option? Of course, here. Why? Oh, because, yes, the hash map returns an option to an optional glyph. All right. Coming back to render state, we have our set transform. Maybe we should say set character transform. That's a little more descriptive. That looks okay. We can change it later. Now, let's implement source text test render state. Oh, that's right. Okay. Now, we could make sure that this is only in CFG test. Cargo watch test. There we go. Now, we're just going to say our horizontal advance is 100. Or maybe we say for certain characters it's less. If that's actually going to be useful, we'll change that. $50 or 10 or I don't know, something. Now, this is interesting. How do we save this? set of transform, we just keep them. So we have a hash map of characters to a vector of transforms. Let's say it's going to be private. Let's say that's going to be a char to a vector of transform. Well, we call this, we want to get the entry. What is it off of entry? Hash map entry, there we go. Or default. Ah, there it is. I see. So we can actually use resize with, provide a default, because we need to make sure that this vector is going to be large enough. This test one doesn't have as much information, or rather hasn't been set up like the other real one. Okay, so it'll truncate it also. We don't want the truncate. Transforms dot. Sure, resize with. And then what do we want it to resize to? Either the current length whatever's greater, that or the new index. You know what? We could just give a default. Give it that function. Semicolon. Come on. There you go. Now, can I use index on that? Line 2 array, yada yada, contains. Looks like it. Index is going to be equal to the transform. And then we should be able to hopefully check that later. And that's going to be an interesting test. How do we assert that these things are going to be exactly the same? We'll figure that out. Okay. That looks good. Expected comma. Oh. Oh, I'm missing a bracket. There we go. Import that. Oh, default is not implemented for the transform. Oh, bummer. These should all be sequential, so I'm just going to go ahead and not use an option there. So yeah, let's move that to the beginning. That one's useful. This one too. I see, so we can create one from the transform 3D. Huh. Sure. Type transform. All right, from transform. Is this a Euclid type? Transform 3D? I think that's a Euclid type. Yep, okay. That's strange. I thought that we were already doing this someplace, but we didn't have to set that up. I feel like I'm missing something fundamental. Where were we doing that before? Hey, Hobby 2000, good morning. Expected comma. Expected identifier. As I think what we'd been using before was multi-mesh instance. And then, oops, multi-mesh. Oh, this is in the source. Let's go back. Okay. Multi-mesh instance down here. How are we actually setting the transform before? Well, we're setting the multi-mesh. That's fine. Material override, blah, blah, blah. Get transform. Set layer mask. Oh, were we setting the translation? We were translating it using a vector 3D. I see. Okay. Yeah. So slightly different. So these things that are just now getting set up, if we have to fill something in, we have to create basically a generic transform. The problem here is that this transform 3D is a Euclid type. Do I have to bring in Euclid, or is this re-exported? Transform 2D is. Huh. Interesting. I guess we could just create a basis and vector. This one has identity. Oh, you know what? Can we just call translate on this? And give it a vector 3? Oh, it looks like it. That's where it is. Yeah, that's doing what I was going to do anyways. Okay, except for the origin bit, but that makes sense. Okay, so we just call translate. Vector of 3D. Is 0 there? I don't remember. Oh, it is. Great. Oh, it's a function though. Okay, so if it doesn't exist, we'll just give it a 0 transform. It's interesting because if we come back here into Godot render state, come into the set character transform, here they do want the transforms all the way through, right? And you can set the instance transform. But that's typically not what I use when I just want to move one of these. I'll set the translation. Let's change this to translation instead. Oops, vector, too many T's. So now we have vector. Let's go back to our render state, change that. Vector 3. Now this one needs to be imported. Okay. Set instance translation, yes, and that doesn't exist anymore. Okay. Now in this case, we have to create a transform out of the translation. Let's go ahead and do that. Technically, set instance. Sorry, I said that backwards. We need to transform out of this. Transform translate. Translation is that. Oh, I changed this a little too early. Okay, where to? Uh-oh, transform. Okay, transform. Expected a vector 3D. Oh yes. This type is a transform. Vector 3. Those errors. Here, if we come back, you'll see the error actually gives us the aliased type here, because Godot has an alias for this. It'd be nice if we could still see what the alias was because we're using the alias. There's the vector 3. Yes. No, you know what? Oh, we should change the test one. Okay, we'll come back to the test one. Setting the transform. It should be translation. Oh, and we only do... Okay, we don't have to do that in both places. Okay, let's just pass the translation through then. Okay, so the glyph takes the translation. This takes a transform. That still doesn't feel right, does it? That should say set chart translation. And then when it needs to, it'll change that. Is it render state? Translation, vector 3. These need to be vector 3s now. That'll be easier to test against. We no longer have to. Does vector 3 have a default? Go look at Euclid. It does. Great. We'll pass it the default function, so it calls a trait function. Cannot find value transform in the scope. Oh, translation, yes. All right, there we go. So now we have the translation set up. What else? Is it compiling? Good, good. No tests yet. So now we're going to go to set up some tests for the multi-line layout bit. Do I have multi-line in its own? No. All right, so let's So we should be able to set this up. We don't have a prelude there, that's fine. All right, that'll build. All the tests will pass. Boom, look at that. Fabulous. So what are we going to test? We're going to call layout on this. So we'll create a new multi-line layout. Have one of these. We need to make this a little bit more generic. Instead of a Godot render state, we could take something else. We could take anything that implements that type. Now the layout has incompatible trait. What? Oh, that's here. That's interesting because we could do this in different ways. We could make the text layout generic. Or, excuse me, yeah, we could make that trait generic. But could we? Let's go check. Where was that? That's in controls text. So this is the control, the text control that's actually on the screen. What does it have? It just has a multi-line layout, which is fine. Problem then would be whether or not multi-line layout needs to implement this a certain way. I guess we could do that. Let's see. So where T is render state, something like so. Oh, D. Zonal advance, great. And we're not tracking the vertical advance on these yet. That's fine. And let's just construct one of these. Let multi-line layout. How about layout? I don't think we need anything for that constructor. Layout.layout. And we have to give it a render state, so we could give it our test render state. Just call it render state. Okay. Now what do we need here? The render state. That should be a mutable reference to that. Okay. We don't have a new on there, which is fine. Does it really need a new? We could do default, or both, new and default. Oops. Okay. All right. And output layout is mutable. since it's not declared as mutable. Okay. And the same thing with render state. So that should mutate render state, and then we can check to see whether or not certain pieces are correct. Did I see the latest Godot blog post? Good morning, Final Spartan. I did not. What do they got going on? Oh, it's taking a moment. Okay, Godot engine, devlog. Is it the devlog? Oh, the optimization report. Is that the one you're talking about? New communication platform? Self-hosted chat platform based on Rocket Chat. Oh, okay. So it's going to be the 3D. Okay. You're not talking about the chat one. Morning, Graticos. CPU optimization. Polling is now done in a brute force way, which is extremely cache efficient. I wish more people understood this. Sometimes you get like queried for big O stuff. It's like, okay, yeah, we understand big O, we understand performance, but big O doesn't take into consideration what the architecture is, how cache lines are going to work, what's efficient, what's faster. That's really cool. I'm doing well. Thank you. Let's see, what else do they have in here? All right. Cache efficient structures are used. Pulling is down on multiple threads. Wow. Before and after. Wow. That is faster. When it goes stable, probably the legacy one. I don't know about this one. This one's not going to have that much need for performance. I mean, I'm purposely making the UI for this game probably this plus a little more. It is not going to be crazy. I'm going to toss some shaders on there and make it look more like a holographic, future-ish 3D thing. A control panel in some sort of dystopian future. But this probably, my game that I'm doing right this second probably won't, but Legacy, I probably will. Wow. So half the time, 15 to 10. Okay, that's crazy. That's. I'm glad they're doing that. Those guys, those people, they're doing good work. I just want to see what this is. Hey, Tommy Luco, how are ya? Morning, Jemmett. Don't remember if no capture is one word or not on there. Ah. Oh, I need a dash dash. There we go. All right, and there's our chars. Oh wow, it didn't actually add any of them to the render state. Oh yeah, because we didn't get that far. Good morning, Bear Doodah. Bear Cool Cow says Muma. Bare Knuckle. Bare Knuckle Waffle. Because when you can kind of tell how long ago you met Bear in Twitch because you'll kind of remember the first name. I think it was Bare Knuckle Waffle. I mean, we even had a little discussion where we tried to suggest new ones, and they were fun. All right, so I'm going to break this into smaller pieces. So what's going on here? The goal of this function is to properly wrap the text. So think of like a multi-line text element. A single line one would be simple, right? You just keep going in one direction, taking the horizontal advance, just keep going. I mean, maybe we should create one of those first. That'd be simple, but why do that? Let's go to the next one. One more hour and you're done, huh? Oh, I thought it was waffle first, and then I mean I remember Berduda. Let's see. At the time, you know what? I've actually got a notepad with some of this in it because when we started doing jokes, right? I captured your name with your jokes, and at that time it was Bare Knuckle Waffle. I mean, maybe I used your second one, or I never met Bare Knuckle Potato. Yeah, you have some good ones in there. What did the farmer say after getting a headache from people stealing his wheat? My grains! What do you call more than one L? A parallel. Dun, dun, dun. Yeah, geometry jokes. I tried to get to target once. I missed. What do you use to comb a cat? A catacomb. Oh, I like this one. What does a kitty like to eat for breakfast? Mice Krispies. Have I used Actix or Rocket? I've used Actix, yes. I have not used Rocket. Is Rocket still requiring nightly? Yeah, okay, still on nightly. The other one that I was looking at was Tide. I mean, this one's using async standard in this example. I think they have the ability to use whichever one you want. But I was looking at this one because it also has SQLX here. I think it would be neat to use. Open telemetry. Oh, yes. My parents have been sending me like horrible jokes. What's the last one? Oh, yeah. My dad said he found a list of Victorian jokes, um, which is likely. He does that stuff. A guy goes into a restaurant and orders a salad. When it comes, there's a button in it. You know, like a button off your shirt. He calls over the waiter. There's a button in my salad. This is unacceptable. The waiter replies, of course, sir. That's part of the dressing. Da-dunch. All right. All right, I'm trying to... Ah, there we go. Perfect. Well, this one looks pretty cool. Rocket, I haven't really looked into it. I've looked into it as much as I've looked into this. I'd be interested to know, like, which one compiles faster, which one can you iterate faster? Because, I mean, quite frankly, if you're using Rust to do this stuff, it's going to be faster than other stuff you've used. Unless you're using, like, goodness, I don't know. Something absurd, right? Oh, jokes. Forgive me, father, pastor, vicar, padre, priest, for I have sinned him. Oh, that's funny. I bought coconut shampoo today, but when I got home I realized I don't even have a coconut. That's so good and bad at the same time. All right, hold on while I toss that into the work chat. Just a moment. Okay. At work, there's a channel on Discord that called Dad Jokes. All right, there we go. Thank you for that. That is fantastic. Yeah, ping me. That's fine. Toss it in the channel. I usually have a window open for it. All right, I saw like, what was it? Was it satellite? What is that other website? Hold on. Probably have it in the other browser. Ah, here. So I'm using Starlink right now for this. Let's turn off the day-night bit. Oh, the rings are fine. Whatever. Show rising. Save. What's these? So where are the ones that got launched yesterday? They couldn't have spread out already. These are the Starlink satellites. I am in the Pacific Northwest. Doesn't look like they're up there yet. The new trains. I think they would look kind of like these here, where they're all clustered together. Oh well. But I'm excited because hopefully that means my connection stability improves. So far, it's been kind of hit or miss, right? I love the bandwidth. They have more than delivered on their beta promise, right? Better than nothing. The occasional skips, if it could get sub-second, I'd be happy, because I think most of the stuff that I have can handle sub-second interruptions. Oops, let's go back here. Let's go back to the code. All right. So the algorithm we have looks like this. Algo. Algorithm. Skip white space at the beginning of a line. This could probably be replaced with skip white space at the end of a line, right? If you've come up to the end of a line, start skipping stuff. And then, let's see. I've worked with Lambda and Rust, yes. My experience with it is that the kind of turnaround time for building and testing, I think, is painful, because it takes a long time on my box to be iterative with it. You have to build these kind of Docker images and run them locally, and it works. It's pretty cool, but it's slow to iterate on. So I don't prefer, like, I actually scrapped the project I was going to do with that because of the iteration time. Now, that's not to say it couldn't be better, but there were some things that just took a long time. Also, analyzing their code base, I think that the libraries out there that are doing these AWS events and whatnot are actually inefficient. Because when you're using a Lambda, you're usually not like calculating prime numbers or something that's CPU intense. You're usually kicking off a couple of requests to other backend services on AWS, which means that you have a lot of dead time for a request. And so I started building up this other project so that you could handle multiple requests at a single time, because a Lambda gets events, but most of the events are handled kind of in a blocking way, in a sequential blocking way. So if we were to draw that out, new file, 1024, sure, black, okay. Because they would get some sort of request, right? So you get an event that happens, and so your CPU spikes there, and then you send off some requests to the back end. Your CPU is dead for a while, right? So here, request, send some back end requests out, and then, maybe like 8 milliseconds later, you get the response, and then you do some more calculations and send that back out to the client. But what they don't do is make this so that it pulls multiple events from their service at the same time, because you could make this 100% CPU if you wanted. And I think that a lot of Lambdas are working in a way where they're mostly idle. So it's a fantastic thing for Amazon, because most of the libraries out there don't take advantage of the CPU that you're actually paying for. So yeah, Lambda here was what I was going to use to change that. And really all this is it's just a bunch of stuff that helps you get set up, figure out what your next request is going to be. You can get next request. You can provide responses to specific things. So imagine, you have 1,000 events that are coming in. You get the first 10 and handle them kind of all at the same time. The CPU could do that. Especially if most of your time is done just waiting. Anyhow. This width up here is really kind of max width or line width. Let's change that. A little more descriptive. Right. And then we just fill up the lines structure based on the ranges. So we have our text here. So we collect that into a vector of characters, and then we create a vector of ranges based on that. So our the vectors are just references. So it should be fairly small and quick. And it's kind of brute force, but it should be fast enough. Now, if we were going to split this into multiple pieces, how do we do that? We could get subsections. Let's split this into functions. So what are we doing first? How do we get a slice back? Why are we working with slices of this char? Because we could just manage slices. Like, why isn't this just a slice? That could just be slices of those chars up there. And that would work. That would be nice. Let's do this. Skip any white space at the beginning of a line. What is this? Line begin index. I don't think we're going to need that if we're working with slices. Okay, we're gonna have something called remainder. Remaining text. This is going to be a slice of everything in chars. It's going to be mutable. Oh, we have to borrow. Oh, you're welcome on the insight. You've been playing with the idea of a multiplayer game hosted completely on completely free services. Yeah, and that could work. I think where you're gonna get pinched with that is state management. Where do you keep your state? All right, so if we just work on remaining text, we use slices, this might work well. Because then we don't need the line begin index. You know what? Before I get too far on this, let's commit it. All right. I'll take that. Yes, yes, yes. Commit message. Render state is a trait type now. It is a trait. There, probably enough. That a little push. Okay. Okay. Back to this. Total characters. I don't know if we're going to need that. Okay, but these two definitely not. Get rid of that. Now here, if we want to be able to strip the white space off the beginning of this slice, we'll say remaining text. Yeah, depending on the game. So you're going to need to have some sort of, let's see, is it a multiplayer game? Did you say multiplayer? Yeah, multiplayer game. You're going to need to sync across instances, right? To be able to talk to each other. That was get UI. Bare knuckle. Get UI. Oh, they're connected via WebRTC. Oh, interesting. Okay. Got it. Yeah, that would work. That would work. So you basically have a rendezvous server. So if we say trim here, now we can either create a trait and implement that for vector. Can we split these? Slice split. What is this? Oh, look at this. Split method on slices. Fantastic. Okay, sorry, I was a little distracted, but I think this is going to be better than what I had. Now, remaining text.trim, we could just have some function called trim, front, something like that. We give it a slice. It skips over some stuff at the beginning. It's either that or we implement for these pieces. Let's pretend we have a trait. We'll call it trim. Is there a trim? Because that would feel really silly. But it's for strings. You know what? We could probably work this. Because they have trim start. Okay. Let's not use this piece here. We'll just use text. And we'll use the trim off of that. Remaining text. Text, we have a slice now. Remaining text is equal to remaining text.trim. Is that start? Trim start. There we go. Morning, fans for birds. How are you? Multi-line text layout. Yes, we are in the process of creating text that will be rendered in a 3D space. So we take font data, we're creating 3D meshes out of it. Whoa, okay, a little too much. It's like Y, G. G is kind of interesting. It's got some sharp edges, big curves. Capital B is also good. All right. We get rid of that and that. This is going to be a vector of stirs. All right, so remaining text, we trim the front off of it. White space for any line. Now, okay, so we can get rid of that. We can check its length and then break if there's nothing else. Because we need to get out of the loop at some point. If there is more text. So if it's empty, then we don't do anything. We just break. Now, skipping the white space at the beginning of the line again. Now, what's going on here? We're looking to see if the current character is a white space. So we're looking at each character in the vector, checking to see if it's a white space. If it is a white space, we'll record its position to know where the last white space is. Now, I think that we can get rid of this whole thing. Oh, wow. Okay. Oh, no. Not that much. Just from here down to the end of the loop. We're going to try to use split. Okay. Oops, wrong one. Split ASCII whitespace. This was a string sliced by ASCII whitespace. When was this added? 134? The iterator return will return string slices that are subslices of the original string slice, separated by any amount of white space. White space, okay. Now, I want this kind of inclusive. Right? I don't know. That's hard to say. Maybe we just have a single space if there's white space. Oh, nightly only. No. I mean, we could implement it. This is challenging because I don't know. I don't know if the text that's going to come in here for the game, it needs to be any more advanced than splitting on actual spaces. So we could do that, and then just improve it later. Now, we could also iterate through these and produce, well, basically a vector, not a vector, an iterator that then also produces single elements that are white space. So we could create a enumeration, one that returns white space, one that returns words, or with two variants, one of white space and one of words. Customer support. Oh, Tommy Luca. I think I am using nightly. We could just go ahead and use this. When is this going to land? All right, let's just try it. So we're going to split inclusive on white space. What pattern shall we give it? Knock knock. Who's there? Java. That's a good one. Now, hold on. Hey, okay. Let me add you to the list, Tommy. The joke list. There we go. All right, split inclusive. Now, what type does that actually take? I'm not familiar with it. Let's go back one. It can take a pattern, and patterns are also, so it can be a stir, char, a slice of chars, or a function, or closure. Yeah, patterns are crazy. Morning, B4141. Well, I think we're just going to give it probably a char. Or slice of chars? I don't know. Let's see. Let's just do some white space first. A char. So that should give us the white space. Now we need to actually figure out how many of these elements will fit on the next line. I'm doing well, thank you. But your wife doesn't like your new car because it's stick shift. Long time ago, I taught my wife how to drive my my Jeep, which was stick shift. And I remember, you know, every new learner, right? You go through that little, that moment where you're trying to get the clutch and the acceleration right. And we were driving past some school. I think it was like an elementary school. And we were going really slow. And there was a little stop sign. And okay, we stop at the stop sign. And then you start to go again. And tires chirp. You're trying to get the clutch and everything right, and everybody turns and looks, and that's fun. I like stick shift. All right, we'll stay going. All right, so we're going to save this. Let splits, I don't know, words, sections, splits equal to that. And then for every one of the splits, we will do something. Actually, let's just toss that for splits, or split in split inclusive. Okay. All right, now for each one of these, we will check to see whether or not it fits. So how about, we need to know whether or not the split is kind of singular, whether or not it's white space, essentially. And does a split of white space, let's see, an iterator over the strings of a slice separated by characters matched by the pattern differs from the iterator produced by split and splitting. By split, in that split inclusive leaves the matched part as a terminator of the substring. I see. So in this case, R has a little lamb. What if they're doing multiple things, like two spaces? I want to see this with two spaces. On two spaces. 3 there, sure. Just have split inclusive, and we will assert that there are 2 there and 3 here, because that's kind of what I would expect. Stable. We went nightly. She's from the US. Therefore, she has no clue. Oh. Okay, so yes, I forgot that there were spaces elsewhere, but it looks like we do get all of those at the end. Okay, that's great. It's interesting though. So we'll have to deal with that. So we need to know whether or not the trimmed version, well, whether or not the current version will fit onto the end of the line. You know, that'll work. That'll work. Okay, because it's white space, it's not going to show up. It just won't have anything that it renders. We'll take the length. Oh, no. We want to know what its width is. That's right. So we have to look up each character and calculate the line width. And the white space. Interesting, because I guess we need to know two things. Is a trimmed version shorter? Because if it, well, here you'll see. Two versions. One. Function. What are we going to call this? Width. Get width, whatever. Width. We will pass it the. I think we have to give it the render state, the text. Ambient t. Yeah, we'll have to define t. And I want to return a tuple. Or do I? No, we'll just return the width, which is a U32 in this case. T, where T is render state. All right, now in this case, we will basically sum up all of the widths. So the first thing that we're going to do is iterate over the text. We'll get the characters, then we'll map that to their width. Text.chars.map. Now chars in this case is a what? Is okay, ch. Good. Now render state dot char. Horizontal advance. And we get an optional U16 back. Render state. Okay. Render state. Now we have horizontal advance. And that'll be mapped to an option, but I don't really want to deal with the option here. We'll say that if it doesn't exist there, it's got a width of 0. We'll say or default. Unwrapper default. Good. Now we have these characters mapped to, is it U16s? Yeah, U16s. And we should be able to sum that up. As U32s. All right, and then if needed, and that's too long, we'll check to see whether or not the trimmed version fits. Because if it does fit, we'll still put it at the end of the line. Now, how do we join spans? Oh, I haven't thought of that. Does stir contains ends with character indices. No, that's not what we want. That's neat though. I wonder if we should have done this into lines first. Probably. We'll add that later. All right. Now we need to know whether or not we could join these. Because this slice is going to be a substring of something else. And they're going to be contiguous. Okay. These lines, they're going to have to be a vector. A little gross. Okay, sorry, I had a little person come in and ask questions. Remaining width, line width. Will be mutable. We'll have to subtract the width to know whether or not we're going to be putting that on there. Oh, we need to know which line we're on. That's going to be a vector new. We'll work on that. Push line. There we go. If it fits, push it onto there. Now, what would happen if something was just way too long? Like it didn't actually fit on its own line. So if the split length, I'm going to use the width. And then if the word width is greater than line width, we're going to put it on there regardless. Probably after splitting it. We'll split it into two pieces. But then we'll also have to push an extra line. This might still work. So if the word width is greater than line width, we'll then check to see if it has white space at the end. We'll trim that off and check the length again. Trim end. Ooh. That's right, they deprecated left and right, and now use start and end. And this should be remaining. Oh, should it be remaining? Now we kind of have a special case, because if the word is longer than the length, it's an odd special case where we actually need to split it. Otherwise, we're going to be splitting on white space. Maybe we should keep it simple? All right, in this case, we will simply create a new line. All right, so we just push that on there, but only up to we need to split that into two pieces. Dot line width, and then from line width on. So this one gets its own line. Oh, we have to loop this, don't we? Because what if it's twice or three times the length of the width? This is ridiculous. So that's going to be equal to the split. Now, the first part will get pushed on there, and we will keep iterating while it's empty. Well, it's not empty. Is there an until? We can loop. No, it doesn't look like that's a keyword. Okay, so the first part that gets its own line. if the part is greater than the whole length. I feel like I should be making tests for this. And this shouldn't be called layout. Multi-line layout. Layout's going to call multiple functions. Function. This is Rust on Godot. Airman CS. And we're going to be using, let's see, let's call it text to lines. And technically, I don't think we have any state that we really need to keep there. We'll just toss that on there for fun. And we're going to need all of that. But we're going to return the lines. That'll return lines. That code goes in there. And this stuff down here moves. Okay. So the first thing we do inside of layout is call this text to lines function. Oops, bouncing around way too much. Render state, text, line width. Okay, there's our lines. Now the rest of this down here is garbage at the moment and unimplemented. But we should be able to create some tests and start to build this out with our tests. This is kind of the whole point. Oh, this. You're not too savvy on coding. Never heard of it. Oh, really? You haven't heard of Rust? Yes. Godot has many languages that it supports. Because they've provided what's called the GD native API, many other languages can provide a Godot interface. So, Rust is here at Rustlang if you're interested. And I think there's a big list of languages that Godot supports. Where was that? Godot Rust. There was an issue in here that was being tracked. Oh no. Godot language support. I think it's in here. And this page shows all of the different languages that have created bindings. Rust, Nim, C#, JavaScript. You can see that some of them have the little ring there. Those are the ones that are made by the Godot team. Inside the Godot editor, I guess you could straight up code in Rust. I don't know if it supports language servers. Oh, they did a video on it. Very cool. All right, I'm going to do this. So the first thing we're going to do is a really crappy test. We will just toss everything in there. Or maybe, yeah. We will push remaining text. All right, so I'm just going to get the let's push everything and set remaining text to nothing. Technically, and that should work. This, okay. Ah, the return type, that's right. So inside of here, we'll return lines. Now let's go to our test. I'm gonna set a marker here, marker capital A. Here's our test. Long lines, we will call it. This is a, oh here, one word. This is a very long line and must be split over many lines. Each character, I think we set each character to be, what, 100, so let's say this line width is 1,000. You're really learning GDScript? And before that you have only used Java and C# on Unity. Oh, cool. And how do you like it? So we're going to call text to lines here. Okay, there's that. Let's see what happens. Expected lifetime parameter. Ah, here. Yeah, GDScript is, to me, it feels a lot like Python. Let's see, in this case, we need to tell the compiler which lifetime we're using here. So we're using that lifetime. There were so many borrows here, I couldn't tell which one was which. Oh, and T, where T is a render state. Is Python, if you're trying to decide between Godot script and Python, I would definitely stick with Godot script. it has a much tighter integration. Explicit lifetime required in the type of text. That feels weird. That feels like I'm borrowing it. Here. I have to give it the lifetime there. That's funny, I wasn't expecting to have to do these, but it makes sense. Yeah, it really is just a custom Python-like language. Explicit lifetime required in the type of text. Oh, yes. Text does need it. Did I not put that up here? I didn't. Where did I put that then? Yes, that needs to be mutable. I get that. Alright, I think I just missed that one. Alright, good. So now everything's all in one. Good. Now let's split this by lines. Let's see, can I explain for dummies, what does it mean that Rust is linked to Godot? Yep, so the Godot engine is written in C++. Okay. And one of the languages that the engine can use is GDScript. But GDScript is kind of a special case where it's very tightly integrated into the engine. All of the other languages use this interface called GD native. Okay. And C++ provides this mechanism of being able to load shared libraries. Game dev unknown, how you doing? It has been a while. So most programs can load shared libraries, and all programs can load shared libraries if, or I say shared libraries, can load libraries if the operating system supports it. And that's what Godot is doing. I'm building a library that's written in Rust, and at runtime, Godot loads it up, and it registers callbacks and registers functions that can be used by Godot. And then when I get into the scene tree, so here, I've got a script attached, and the script can also provide variables and things like that. But the definition of the script is here. It just says the class name is this, there's no code, and the library that I'm using is called control.gdnlib. And then if we look in here, we'll see that these entries, let's see, on OS 10, point to a library. So all of my code is compiled down to machine code and is run, it is just executed by Godot. So I still have to associate the code like you would a GD script file, but it's pointing to a library. Yeah, it's hard to say based on like kind of your experience level. Feels like you're kind of new to a bunch of this. In C#, I don't know if you've been introduced to their library system, where you have to register code, and they have DLLs as well. I don't think their DLLs are machine code though. They're for the CLR. Would love to show me native integration. You did some tests. What is native integration? Let's take a look. So tell me, what are we looking at? When you, let's see, when you install any plugin and enable it, take a little longer because it will install the necessary files. Okay. Oh, I see. That's cool. That's really cool. And how does it know how to build? I mean, there's so many different build tools for C++. That's pretty cool. That's nice. So Airman CS, Rust and C++ code both get compiled down to machine code, right? And so there's no need to transcode from Rust to C++. They both produce the same sort of output, C++ and Rust. What is my current workflow? So what I have set up is I'm using, let's see, where is it? Well, no. Go to GitHub, Godot Rust. I'm using, not the template. I don't actually care for the template. It doesn't match my workflow. I'm using project utils. And project utils has a mechanism for creating the gdnlib and the gdns files. So inside of Rust, Rust and Cargo understand that you can basically build a executable as part of your build system, as part of your build. And in this case, there's this build.rs file, so this will get compiled before my build, and if I make a change to it, it'll get recompiled. It understands it. So basically, this knows how to create the GDNS and the GDNlib files. And I put this as part of my tooling. So if we go to here, you can see that at the top level, I have this build.rs file. And that's what causes the other files to get generated. And then in another window, I simply run cargo watch-x build. And it'll keep rebuilding that GDNlib. And then I have to go through the painful process of closing and reopening Godot. Because I'm using it as a tool library. All right. So split in remaining, split inclusive. Oh, what? Takes 2. What's it take? Oh, the render state, of course. Why does it take a mutable reference to the render state? Yes, game dev unknown. And so you saw Rust bindings for GD native. I think that's the main thing you need to compile both to. Yeah, so Airman CS. Godot Rust, it builds and it compiles down to, well, you use this when building a library. So this is some code. It's I guess we would call it a crate in Godot, in Rust terminology. And it's a bunch of code that you can download and use. And it's done automatically using Cargo, the build tool for Rust. And these bindings are there to help you interact with the GD native API that Godot provides. So my library, I basically just tell Godot, load this file. It's native code, and call a specific entry point, and it'll initialize itself, right? It'll call back into Godot and register a bunch of functions so that they know how to talk back and forth using the GD native API. The GD native API is basically just a Rosetta Stone, if you will. And I guess Rosetta Stone isn't quite the right terminology, because that's more translation. This is GD native. That API is really just an interface. Just a specific set of functions that you can call and register your own native functions inside of. Oh, interesting line width. I've been coding for a little while. Let's see what time we got. It's about 9 a.m. Okay. going to get rid of those. And we don't want to just keep doing that. We want to Oh, you're welcome, Airman CS. It's not quite like that because Godot GD native isn't interpreting the Rust code. It's executing it. So if you will, I am extending Godot at runtime. I pull more native code. If the C++ code is, think about it this way, that C++ Godot code is compiled down to machine code. Okay, and that's what the machine runs. And part of that machine code is the ability to load more machine code. And that's what's happening here. We have the C++ Godot code, and then the Rust library code, and both are compiled down to machine code. But the Godot code I've configured to load the Rust machine code. So now we have just one big blob of machine code. Part of it was created from C++, part of it was created from Rust. And now it all just runs. Yeah. I guess at a fundamental level, that's I guess how you could think of it. It gets a lot more technical really quick, but all right. So for the really long word, what are we doing here? We've split this remaining text, inclusive of that. We're looking at the word length of it. Okay. Now, for every single word in there, we're going to figure out what line it should be on. And we are going to extend this line I'm going to move that down a little bit so I can see it, because we don't need that outside of there. Yeah, that's about right. And that the machine code from Godot has all of the instructions for the engine, right? For how to draw a triangle, how to animate, how to play sound. And Godot machine code is basically, the Rust machine code is basically saying, please draw this triangle for me. Please play this sound. Please turn this triangle 90 degrees. And then the other machine code, the engine, the C++ code, is executed and does that. I wonder if I should be treating this a slightly different way. The while should be on the outside of this. So do I have like an API for Rust Godot? Yes. And it's quite a large API because it's basically all of the Godot API available to Rust. So when you come into the script and you search the documentation here, all of this stuff is inside of the Rust API as well. Or, excuse me, the API that is available to Rust code. So all of this is there. And then the entire Rust language is available, right? Because I'm using Rust. And then anything that's available to Rust, I can use. So, I mean, if I wanted to, I could use other libraries that are available to Rust, which I'm doing. I'm part of the library I'm using knows how to read TrueType fonts. I didn't write the TrueType font reader, but there's this crate called TTF parser. So I'm using that in Rust code. And then I'm also using a tessellating library that is also available to Rust to create the triangles from that other code, or from that other data that the font parser gives me. Hey, you know what? I'm doing this in the wrong spot. This shouldn't be word width against line width. It should be checking to see if it's longer than the remaining line width. And if it is, and it's longer than the line width, then we split it based on the remainder. Okay. That's funny, but no, yeah, it's I wouldn't say simple, but it's nice to be able to use Rust because I like Rust. And the GD native, excuse me, the GD script API is a wonderful API. I highly suggest using that. I'm in that part of my career where I'm trying to learn Rust, so. All right, so we have the word width here. So the first thing we look and say if the word width is greater than, you know what, let's handle the easy case. If the word width is less than the remainder. So if it's less than the remaining line width, then we'll add it. All right, that should be simple. Line.push, what I call it, split. What's that word? Let's call it word. And now we have to subtract the width from the remaining line width. Okay, so minus equals word width. Fantastic. And if that happens, we're going to continue and go to the next word. Let's you see, you understand, but as mainly an artist, you will keep the GD script. Oh yes, absolutely. If you do not need anything more than GD script, if it does everything you need, that is perfect. Just continue to use it. The word fits, add it to the line. Okay, now what if the word does not fit? If the word width is less than, let's say, the word fits without filling spaces, add it to the line. Add it to the line and create the next line. There. Oh, I like this. This way we're doing this better. Whoa. Okay. I think GD script will work for an incredible portion of all games out there. Probably very, very little that you would need to worry about. And let's see, we'll push that. Continue. I'm going to go ahead and toss a semicolon on that as well. But we need to create the next line. Here, Mincy, yes, you are very welcome. You're very welcome. Oh, and did I paste that link into chat? One with all the languages.
The setting could hardly be more perfect.
Well, we could go back and rewind if we need. All right, so if it's trimmed and it fits on the end, great. We'll add that. You know what? I'm going to write tests for those two. Quick. We're going to comment out this test. Do we ignore a test? Do we do ignore? All right, now we need some more state. Oops, what did I do? Oh, I was also squishing the other key. Now each one of those, if we say the line width is, let's say, 600, should now fit on individual lines. Uh-oh, that's running forever. We didn't reach our exit criteria. Because we have this loop here. Do we need that loop? No, I'm not using that. Oh, of course, breaking.
Travel through the mountains, walking through this wasteland. My eyes are fixed on the horizon.
Yeah, we have no lines.
Holding on to what I am.
That's not what I expected. All right, so simple case. I should be using asserts and not debug. Let's just say there's nothing. The lines assert equal. Now does this? I don't remember the order. I usually do expected then actual. Oh, it doesn't know the type. This is lines. All right, so that should succeed. 2 pass, yay. This one here, let's see, this is the actual. Expected is going to be equal to a vector. Here, use the macro. Oh, I spelled vec wrong. Look at that. Oh, that, and I didn't surround those with quotes. And I think each one should probably have a space at the end, because I'm not trimming those when I put them on. Oh, do we not use, we're not using layout? Oh, we are. Oh, but it's just not, it's not mutable. Fine. All right. So yes, that should be the same. It's not. Well, let's make it the same. So we create a new line, and as we go through these words, let's say we split inclusive, not spit, split inclusive for spaces. If the word fits, add it to the line. Lined up push word. Okay, why is that not happening? Does this not return anything? Because we should be coming in here. That width, the word width should be less than the remaining line width. You know what? We're not resetting the remaining line width when we get to a new line. Oof. Okay. That shouldn't matter. Even if we were getting in here, we should have seen it. And we return lines. So what's coming through? It just starts here, skips over this, gets straight to the end. I think we have to push the last little one, but that shouldn't matter. Unless they're all ending up on the same line, and that's never getting pushed in. Oh, we're getting this. Okay, so that, it did go through once. That's it? Like, and then the rest of the time? All the other words are shorter? What? Why would this not work? All right, let's add some debugging. Word width. About word. Oh. 300, 5557. That, and we should only push that last one on if it actually has something. Hey, Sarcastic Dante, how are you? If not, line dot is empty. Then we do this. Okay. But it's going through and it's looking at each one. I thought I'd give it, what was it, 600? So each one of those should work. Yeah, 600 is the width. Okay. Remaining line width. Oh, we do not handle the case where we've made it through both of them. There is still something remaining, but the word doesn't fit. So in this case, this is where we start to get into that other situation. Yeah, I'm doing all right. What is it, Thursday already? Goodness. Starlink's tossing more satellites up there. Hopefully it'll make my internet better. All right, now in this case, remaining line width, okay. So we've handled the case where the word fits. Let's simplify this example. I'm going to set a marker here, marker A. You know what? I don't know. We'll leave that example because they all fall into the same case. And the case is that the word is, arguably less than the width of a line. See, should we use a trimmed word width here? Maybe. So then we just push it onto the line, which is basically this one. Should create little closures for this. Let's do that. I can't because of ownership rules. Because I would need two. Oh, I would like to. I would like one that we'll clean this up as we go. Let's get it working first. All right. Panicked. Attempt to subtract with overflow. Oh, interesting. Line 79. 79. That's not the right spot. Okay, but it must be here. See, which one do we want? Do we want saturating sub? And it's going to be the same thing here. No, this one we just reset it. About here. No. Yeah, we're implementing word wrap. All right, what did we get this time? Oh, it is correct. Wait, this is not correct. That's all in the same line. That's lines and words. So those all ended up on the same line. They should not have. Okay. 0. Remaining is 0. 0. 0. In the case of 0, so this is bizarre. The word width is 500, right? And the remaining 600. So we were left over with only 100 remaining width. Is 300, right? 3 characters. They're all set to 100 in terms of width. That's great. And then, so this one doesn't fit on the same line, so it should have created a new line. But where did it get pushed? Oh, less than line width. Of course, it gets pushed here. All right, so if it's If it's greater than line width, we're going to do something special. If it's not greater than line width, we're going to push the word and subtract. Okay. Should is missing before fit. This is some text that should fit. Huh. If the, oh goodness, I've just lost all the state in my head. Yeah, we have a special case for the word being longer than the line itself. We'll handle that after we get the basics. Let's see, is it faster to code or more controllable? It is safer. So many of the things that you see in C++ or C, like you don't get the buffer overflows in Rust. You are able to control state changes on data in a multi-threaded way in a more controlled manner. Not more controlled manner, but in a manner that the compiler checks to ensure is correct. So the compiler does a lot more for you, and it validates your code to, I guess, a much more rigorous standard. All right, so in this case, we're really needing to see that there is no more space left. So here, if trimmed word width is greater than the remaining line width, then we reset the line width. And we also have to create a new line because we cannot fit the current word on it. And then we push the word on there. Which feels weird because here we shouldn't hit. I don't know about those two being in here. We'll see. I am editing in VIM. And we do have some more commands. I've been using it for 20 years, so it's good enough. I think that, you know, you should probably pick an editor and just get really good at it. Yes, the war. Oh, interesting. So we ended up only getting fit because I forgot to push. Oh, I forgot to push the previous line. Lines dot push line. Gotta shove that on there. Ah, two passed. Okay. What about long lines? Let's say long words. Remove the debug. Alright, let's just comment that out for a moment. Same keyboard for the past 10 years. Literally the same keyboard. Okay. Let's look at this one now. Long words. Let's change this. This has a very long word in it. This has a very in it. What? In okay. Oh, this is it's running all the tests. Test. What was it? What were we testing? Test long words. This has a very long word. Wow, so we're missing a couple things here. I'm going to split this into two tests. So I want to test two things. One, that it correctly splits just a very long word correctly onto following lines. So how many characters are here? There's 14. Oh, okay, 15. Okay, so we should be able to get those two words on two lines. Long word. Let's do this one first. Cargo watch would kill your work laptop? Ah. Oops. It's doing both of them. Very long. Okay, I want to split this into two lines. Let's figure out what should that look like. Let's say this is actual. Expected and actual. Now, we're going to say it needs to be trimmed at 10. E, 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 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the R's. Now we have the Y's, 1, 2, 3, 4, long. This should end up like so. All right. Should have been like this, ended up as, oh wow. So we had an empty one at first. Ah, because our check to shift that on there is not correct. Okay. Wow, so it got that empty. That's surprising me. So where we push lines here, we should only do that if line, well, it's not empty. Good. Now we have to split that one. So if the trimmed word width is greater than the remaining line width, and we're pushing that word on there, I mean, maybe I shouldn't be worrying about this. So this is pretty good. All right, so we create a new line if there isn't any room. Then we force this word into it regardless, even if it's too long. And the remaining line width is left there, but we're missing words in the other test, aren't we? There. Oops. Let's see, this is going to be a number of lines. Vector. So in this one we have this space has space. What is that, 5 and 9? That should fit on one, shouldn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh man, that A might actually fit. This has A. Very. Just copy paste that. Oop. How many of these long word are both like that? Okay, I expect it to be like so. Oh, okay. So it did get this space. Oh, interesting. I think that reveals an error. Because when we push the word, we don't push the trimmed word. That needs to be extracted into variable. It is part of the game. Audio-based psychological thriller, which also means that what did I save? Trimmed word should be tossed in there. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. That should be 1,000. Grumble, grumble. Okay. Okay, let's do less than or equal to. I'm going to debug the DBG trimmed word. I just want to see, is this getting added there? Should see some debug for that. Trimmed word, A. Oh, this has a very long word in it. What happened? Run the test again. No, just one. Long words, plural. This has a, that's the expected, and the actual. See, in and it are on separate lines. Long word. Oh, sure. I forgot to split those up. My mistake. But why? Why wouldn't that last one work? I mean, we're missing this whole section. It didn't get pushed. Oh, it didn't get pushed. So basically what happened was, here, we push that on there, and then we create a new line without adding it to lines. Ay, ay, ay. So we dropped that line. How was that working before? Or was I looking at the wrong place? Okay, and very didn't get that trimmed. That's okay. Now let's see. This is pretty good. It's nice that we have it broken up into lines with wrapping, etc. You know, this should be its own crate. All right. I have no idea what that says. What is it? Here, let's toss that into Google Translate. Copy. What does this say? This is a very long sentence. Thank you. All right. Let's try one. I don't know if those characters are part of the font I'm using, though. Let's see. Oh, here. I don't think there's going to be anything in there. How much did I already know of Rust before coding for Godot in it? At that point, I had spent maybe half a year in Rust, maybe 400 to 500 hours in Rust. Hmm. Yes, I wonder how many hours I'm currently in. Let's see. Content. I'm probably 1,500 hours in on Rust in terms of learning Rust. I am a full-time dev, and here in just a couple minutes, I actually need to bail and actually do my day job. So I will do that shortly. Let's check Unicode though. Let's see what it does. Do they fit? Ah. Yeah, it doesn't handle that very well. Now, which text is this? Is this left to right text or right to? I guess it's left to right. See, it's Japanese. Oh, dog just came in. Day jobs always get in the way of real jobs. I'm using this as a way to learn Rust, right? And it's worked out pretty well. And now we need to be able to fold that, and that's a really good example that hey, this should be wrapped. We should probably do this every 300 character, 300. All right. What? Oh, hold on. The dog doesn't have her poof. Let me go fetch it for her. All right, now she's got her poof to sit on. Yeah, after work, kids are up and awake and gonna spend family time, all that stuff. All right, let's just do all the tests. All right. So we need to be able to split this word, and it's going to basically look at these like a word. Just split them. That should still work. All right, so in this case, we've gone through. If the word will fit on the line, we put it on the line. If it needs to be trimmed and fit on the line, we'll put it on the line. If it doesn't fit, we're going to create a new line. And it feels like we need some sort of loop in here for things that are longer than one line. What else do we have in terms of split? We can give it the pattern. Divide it into two. We could do that. Where are we going to put this? I mean, should we put that? Feels like it touches this a little bit. Either that or this here should change. Oh. Or I can't really come back to this. Well, we could put a loop outside of it. Oh, that's one word. Oh, that's rough. Yeah, I have no idea how that would work. I mean, is that even, because those are two Unicode glyphs, right? And there isn't a way to know that the next piece would be part of that word. And you wouldn't have white space between them. You would just know that this is a word. I'm guessing this is going to be enough, though. I mean, maybe we don't deal with super long words. Like splitting a really long word across lines. Wow. My page up and page down have gotten really, really short. Okay. I think this is probably enough for now. Let's just touch up some of the tests. Am I going to worry about that? Probably not. And this one, very long. It would be nice. It would be nice if that worked that way. But I think for doing that, I would need to have some other sort of some other iterator here. Like in this case, iterate on this middle portion if so that the word can be broken down. Oh, it's in Java, not C. Oh, interesting. Hmm. This will be used for when the game goes multinational and is a gigantic success. Wow. And are these words split at the right place? Oh, wait. User dictionary. Oh, so you have to have a dictionary for this. Oh, wow. That would be complicated. All right, I think I'm going to loop on this. Because if I do that, and I could split up the word and do parts of the word. Essentially, I could inject 3 words here. Well, if it's 3 words, 3 lines. If it needs to be split upon 3 lines, we could do that here. How do I get an iterator over a slice that splits where I want it to? Split n pattern. Well, patterns do take functions. All right, let's try this. We're going to give it a function, right? And it'll use that to do this. Let's see, do they have an example of this function? What does a function look like? Did I miss it? Oh, split here. And in this case, I would have to know what the length is. Because I don't want to split it on the type of character, but the length. Ah. We'd use a proper iterator. I don't wrap by character limit, I wrap by character width. Oh, look at that. Huh. That's cute. Because I don't want to force this to use fixed width fonts. In fact, I'd like to not use a fixed width font, even though my font is probably fixed width at the moment. Roboto mono, yeah, monospaced. So right now I'm just using Roboto. Is that all the glyphs or just some of the glyphs? Apache license. Yay. All right, let's go back. Let's grab the regular one. Let's see. Do I want to download the font family? Probably not. Oh, save file. Okay. Looks like I have a couple of them. What did I just download? Okay, one with a 1. But does it have a space or not? It does not look like it has a space. All right, now we're just going to use Roboto regular. There we go. Oops, wrong one. Come back over into term 1. All right. Unexpected token. Oh, because of the slash. That. Oh, how interesting. All right. Well, let's give it a build. Still no. Oh, mod has a lot of white space at the end. Really? These all look fine. I know this looks ridiculous. And it feels like all I did. Let's see if I do test. Test doesn't even work anymore. Wow. What did I change? That was just about a regular. How is that going to mess this up? Like, we downloaded that, we created a directory, we removed it. Is it Godot? Let's close some of these. Godot's gone. Unexpected token. Where is the unexpected token? I know, right? I mean, not long ago, we were building, and then we just brought in and changed Roboto. Oh, because we're including the bytes. Is this the exact name of that file? Oh, where am I? Wrong directory. Maybe it's not exactly right. Hi, looks right. All right. Mono. Still no. Is that even the right place? Like, let's say we give it a file that doesn't exist. Okay, no, something else is going on. What changed? Don't care about that one. This, sure. That looks fine to me. Maybe it doesn't like that, but we saw the test. I don't know, I'm grasping at straws. Built around the custom build command, which has not changed. This is not okay. We'll go clean. Maybe some bad state. Let's pull in the latest nightly. Oh, that's a great idea. Stashing it and trying again. Let's give this a minute. This will literally take a minute, maybe a little more. You'll have weekend plans? Actually, I gotta get going. So this is probably a great point to stop at. Who should we raid today? Let's see. Hardliner's doing C++ today. Got Anti-666, he's doing Atom again. Let's try that one. And just so you know, he's been building a compositing system for streaming that's got these really sort of cool web interface hooks to it. And you're welcome, Airman CS. Oh, I will have fun at work. I will. I like some people there. Some of them are good people. You guys know who you are. I love you. Oh, you know what? I'm gonna cancel that. We're gonna raid Tadzo. He's doing Rabbit and Q stuff. We're gonna switch. All right, take two. Take two. I'll say, do I work at game dev? I do not. I do not. I'm a web dev. I've worked on server stuff, on client stuff, and it's currently on the client side of the swing. I think the next place I work will probably be server stuff again. All right, y'all. Take care. Till next time. Bye-bye.